Welcome all. So let us start with the module 1, which is about basic maths and its application. This is session 1 where we are going to discuss some topics, and let us start with differential calculus. Okay, so what is differential calculus? Basically it is the differentiation, right? Differentiation of y with respect to x, with respect to x, which we write it as dy by dx. So dy by dx is differentiation of y with respect to x. We will go from very basics. So what is x and y? So first of all we have to understand some concept about function. What is function? So let us say y depends on x. Y depends on x. So we write y as a function of x. But this is in general a relationship, like there is a relationship between two variables. Whenever you draw a graph, there is x and there is y. X is called dependent variable, and y is called independent variable, right? Independent variable. So now the thing is that the relationship between x, y can be any type, but all such relations may not be function. Function is a special type of relation that we want to understand. Let's understand function, then we will come to again dy by dx. So when we have a function, so function is what? Function is a special type of relation. It's a special type of relation. Okay, what is special type? That I will explain here by graph. So suppose I draw the xy graph, and let's say the function is like this, okay, and one relation is like this, okay. Both are parabola, kind of parabola you can take. Now here one of this graph is a function, other is not a function. How? So we say that it's a vertical line test. So if you draw a vertical line, let me draw vertical line anywhere I can draw. Okay, let's say I have drawn here. You can see it is cutting the graph only at one point. I can draw here, anywhere I can draw. Here it is cutting only at one point. But when you draw here, the vertical line is cutting 2 points, or it may cut more than 2 points. Okay, so this right hand side is not a function. So left side, this is a function, and this is not a function. Not a function means it's simply a relation. It is a relation. So x and y are related in such a manner that if you draw a vertical line, here you can understand that this vertical line is cutting at one point. Here also it is cutting at one point. But here it is cutting the graph at 2 points. That's why it is not a function. This is the very basic that we have to know as far as physics is concerned. We don't have to go more detail into mathematical definition of that. That you will be studying in math separately, right? Here the graph should be cut only at one point. Okay, this is called vertical line test, and if it is passing the vertical line test, then it is a function. Otherwise it is not a function, it is simply a relation. Okay, let's move to the next. Okay, now when you know that there is a function and xy relationship is such that there is a function, then we will understand what is meaning of differentiation, physical meaning of dy by dx. What is the meaning of dy by dx? Okay, here y is the function. Okay, various types of functions can be there, that we'll separately discuss, but we will first understand physical meaning of dy by dx. Okay, so what is physical meaning? That means it's interpretation in physics. What is the understanding about it? Okay, so suppose there is a graph. Basically from graph we have to understand everything. Okay, x, y, let us say this is a graph between two quantities, and let's say the graph is, I'm just drawing a rough diagram. Let's say it is, like this. Okay, this is a graph, and let's take any point here. 2 points we can take on this graph. This is a point. Okay, this is point A, right? And of course the values of coordinates will be x comma y. Let us say this is x comma y. Let's take any point B. This side is a different point. Now to go from A to B, or to go from the first point A to any other point on the graph you want to move, right? So you have to change x and you have to change the y. So let us say this is x plus delta x and it is y plus delta y, right? So here x is the x coordinate of first, y the y coordinate of the point A. Delta x, delta b is the changes that you have to do, right? So you can represent it like this also. This is x from here to here, and this is what is y. And similarly you can plot here this. So this distance is x plus delta x. So this is the point delta, and this length is delta x. Similarly, this total length, final length, is y plus delta y. So till here it was y only, right? Till here it was y. So this length must be delta y, isn't it? So basically there is change, and this, this is representing what is the change here. Okay, this one, this length is going to represent the change. This length, right? Delta x, this is representing delta y. Okay, now let us join the line AB. I am going to now join the line AB. Okay, so let me join the line AB by a straight line like this. It may not look exactly, but approximately you can take that this is passing through point, right? This is point A and this is point B. Now this line is going to make some angle with x-axis, or a line parallel to x-axis. So that angle is, this angle, right? You can take anywhere line parallel to x-axis, that's the angle theta. Okay, so this angle theta is the angle made by the line AB. Line AB is like a secant. This line AB is called secant. Okay, this line AB is called secant. Why? Because it is cutting the graph at 2 points. If it is touching the graph at 1 point, then it will be tangent. Right now these 2 different points, right? So this line AB is secant. Now this theta, if I take tan theta in this triangle, which will be delta y by delta x, correct? This tan theta is also known as what? You must be knowing about it. A straight line. This is the slope of a straight line. Slope of secant AB. AB is a secant. So this tan theta delta y by delta x is called the slope of the line AB. Line AB is secant here. Okay, and a line has a constant slope. So this line AB has this slope at tan theta delta y by delta x. That is what is the slope of the secant. Now let us understand what will happen if delta x is going to be very, very small. Delta x tends to 0, we will apply limit on this. Okay, so this ratio delta y by delta x, we are going to apply limit on this. That means the 2 points A and B are going to be so close to each other that they will merge into a single point. Okay, so let us consider the graph again, but this time let's draw, xy, and the graph we are going to draw in such a manner that both the points have become a single point. Now the point A or B are the same point, and now again you can draw a tangent to this point. Okay, this is like a tangent, isn't it? So this point AB, here this line is a tangent, and now this theta, when you take that tan theta, what is this tan theta? This tan theta and previously the tan theta not the same. Okay, so delta y by delta x, when you apply limit delta x tends to 0, this ratio is called dy by dx, and this dy by dx is nothing but it is tan theta in this diagram, which is the slope of tangent AB, because now this line AB is a tangent. Previously it was not tangent. So what is the main condition? The main condition here is this limit delta x tends to 0. Because of this condition, these two points are merging into one point. That's why this point is no more two different points, the same point, and the line is the tangent, isn't it? This line is tangent, right? That's what it is. That's the physical meaning of dy by dx. Now, so let us repeat what is it. So dy by dx represent. What does this represent? It represents slope of tangent to the given graph or to the given function, or graph at a given point. Okay, so suppose if the graph is like this, okay, different types of graph it can be. You can take a particular point and draw tangent here. So when you draw tangent, right, you will see that it is touching, of course, here, and this angle which is coming theta, that tan theta is dy by dx. That is what is dy by dx. So different point, if the graph is a curved graph, right, at different points theta will be different, because at different point tangents will be different. Right, suppose you draw tangent here, so this angle theta is different. So this represents slope of the graph at that point. Okay, and if the graph itself is a straight line, let's say if a graph is a straight line, so any point you take tangent, the tangent is the same straight line itself, right? So that's why we say that a straight line has constant slope. Why a straight line has constant slope? Because dy by dx or tan theta is same. Tangent is the line itself. Okay, so that's the concept, that's the physical meaning of dy by dx. Okay, so now let us take few questions based on which we can understand. Okay, let us take a question. Suppose I give a question number 1. Suppose this is a graph, xy graph, and let's take a function like, it is like this. It may be continuing like this. Now what is dy by dx at few points? I am giving few points. Let's say this is point A, this is point B, this is some point C, this is point D, this is point E. Okay, this is a curve. So I have taken 5 points. You have to tell what is the signs of dy by dx. So at A, dy by dx is what? Is it positive? Is it negative? Is it 0? 3 things you have to tell. either positive, negative or 0. Okay, so I will make it like this, either positive or negative or 0. Three things you have to tell. Okay, so what it will be, tell me at point A. So you can draw tangent there, right, like this, and you will see that it will be making theta. This theta angle is acute here. Because of acute angle, slope tan theta will be positive. So it will be positive. Similarly, you can take point B. At B, what is dy by dx? If you take point B, here you can clearly see the tangent. When you are going to draw at this point, it will become flat. It will make 0 angle. Similarly, the same case will happen at point D. Here also theta will be 0. So tan theta will also be 0. So at B and D, right, B and D, dy by dx is going to be 0. Okay, dy by dx will be 0. Okay, similarly at point A and E also, here also E point also has same positive slope. Values may be different, but slope is positive at E also. Similarly, if point C, if you take at C, what is dy by dx? Now here dy by dx, when you draw tangent at point C, you will see this point is going to make obtuse angle. Because angle is measured from positive direction of x-axis taken in anti-clockwise direction, right? This direction angle is taken from positive x-axis. Okay, so this is positive. Otherwise, when you go like this clockwise, theta is considered as negative. Okay, this theta is considered positive. So we are going anti-clockwise from positive. So here you can see theta is going to be obtuse. Because of that, tan theta will be negative. So here tan theta is coming as negative. So slope at point C will be negative. Understood? So that is why now here there's an important concept that at maxima and minima slope is 0. That's why we say at maxima and minima slope is 0. Okay. Then dy by dx is also, let's note this important point. Dy by dx is equal to 0 at maxima and minima. See, what is maximum minima? Maximum minima is the peak point or the valley point, right? Like this. This is the maxima, right? And this point is the minima. And there is a difference between maximum value and minimum value. Maximum value and minimum value can be different. For example, suppose there is a function which is defined like this. Okay, and this function is defined within a particular region. Let us say they give this values of x. Within this region, you have to find maxima and minima. So maxima means here, let's say this is the maximum value of y, and the minimum value will be this point. Okay, so maximum value and minimum value. This you have to understand. So for maxima and minima within a particular region, it is not necessary that dy by dx has to be equal to 0, but wherever dy by dx is 0, within that there will be maxima and minima at those 2 points. Okay, so whenever they ask to calculate maximum minima of a function, we have to see dy by dx is equal to 0, and also we need to see within the limits. That means we should have some idea of the graph. For example, here the minimum value you can say at this point is minimum, but where is maximum value? Maximum value where it is, then you have to see the value of y within this region is maximum at this point. Okay, right? So that's why this is the maximum value. Okay, it may not be maximum, it may be little bit confusing, but it's the maximum value. So maximum minimum means maximum value, minimum value, but maximum value and minimum value need not be maxima and minima. Okay, this is important thing to note. Then what is next? Next is we have to understand what is double differentiation, because double differentiation has lot of application also in shape of the graph, that also we will see. Double differentiation d square y by dx square. What it is? So suppose if you take the graph like this, okay, so you take here the slope dy by dx, slope here, slope means dy by dx, dy by dx is positive, here dy by dx is 0, and here dy by dx is negative. Similarly here dy by dx is 0. Again this side when you go, dy by dx is positive, right? So now you can understand here that at this point it is positive, dy by dx is 0, dy by dx is negative. So the slope is decreasing as value of x is increasing. That means as we are going from left to right, the slope is decreasing, right? From here to here as we are going, the slope decreases. Slope decreases. So double differentiation means d by dx of dy by dx. Okay, so it is the rate of change of slope. Rate of change, how slope is changing, is it increasing or decreasing? It is decreasing. So for this type of graph it is going to be negative. Okay, this you have to understand. So when you are going from this point to this point to this point, this type of shape is known as convex shape. So this shape is convex shape. So for convex shape, double differentiation is negative. Just the reverse way also, when you go from, let us say, this point to this point to this point, so slope is going from negative to 0 to positive. So slope is increasing here, right? So when you are going like this, slope is increasing. Slope increases. Slope increases. So in this case, the double differentiation d square y by dx square is going to be positive. Okay, because slope is increasing, and this shape is called concave shape. Concave shape. So the shape of the graph gives us some idea about what type of shape it is. That means double differentiation. Double differentiation is giving us the idea of the shape of the graph. Okay, whether it is concave or convex. It's not that we know exactly whether it is a parabola or hyperbola. Nature of the or the function, type of functions, we may not be able to know. It may be log function or any function, but we can tell the shape of the graph, okay, by double differentiation. So this is important, right? So these concept of differentiation, physical meaning, single differentiation, double differentiation are important, okay, right?